Hi everyone, I am Nure Mujassim from Data Science branch. Here I am here to provide a brief overview of a assembly level programming language. Assembly language programming is a technique that enables direct communication with a microcontroller's hardware using symbolic instructions. On the 8051 microcontroller, each command corresponds closely to actual machine level operations, allowing precise control over registers, memory, and input or output devices. Assembly is used to craft programs that execute arithmetic logic, data transfer, and control instructions with maximum efficiency. The significance of assembly programming lies in its ability to manage the fundamental operations of the CPU and memory. By working directly with registers and memory addresses, as in the division experiment, with values at 74H and 75H, and storing results at 76H and 77H, programmers can optimize program execution, perform rapid arithmetic, and manipulate data at the hardware level. It also provides insight into how status flags, that is, 0 and carry, affect program control, error handling, and decision making during operations like division. Here's a full step by step explanation. The purpose of this program is that 8051 assembly program divides two numbers, storing both the quotient and remainder in separate memory locations. Here we see move a comma 74h. It is the load dividend, loads the number from memory address 74h. 74h, it's the dividend, stores the memory accumulator, that is A. Next, move b comma 75h. It is the load divisor and it loads the number from memory address 75h, that is the divisor, into register B. Now, for performing the division, DIVAB, it divides the value in A by the value B. After execution, quotient is stored in A, remainder is stored in B. Move 76H, A. It stores the quotient from A into memory address 76H. Now, the remainder is stored in 77H. SJMP means it ends the program infinitely, and END is the end statement. It marks the end for assembler, tells the assembler no more code follows. Now we'll run this code. Here in this simulator, we'll adjust it to 70. Now in this dividend, we'll give the value as 15, and in divisor it is the 4. Here in this 15 value, the decimal value is 21, and we'll divide it by 4. As we divide, the quotient is stored in A and the remainder is stored in B. The value of A is 5 and B is 1.
My name is Aishwarya DT. Now I am explaining the storage reminder. This program divides the two numbers stored in a memory and stores only the remainder in specific memory location. First, move a comma 74h loads the value from memory address 74h into the accumulator A. Next, move b comma 75h, which loads the value from memory address 75h into register B. Next, DIVAB, which divides the value in A by value in B. After execution, quotient is stored in a A and remainder is stored in a B. Move 77H, B, which stores the remainder from register B into memory location. SJMP means which makes the program loop indefinitely, so no further instructions are executed. End means which marks the end for assembler. Now we will run the program. In 74H, we will put the value 15 and in 75H04. After running the program, the quotient is 05 and the remainder is that is B, that is 01.
Hello, I am Lakshmi GB. Now I am going to explain the division by zero handling 08051 assembly program including step-by-step description and simple output. This assembly code divides two numbers and safely handling division by zero. Using the zero OV flag, the quotient is saved at one memory address, the remainder at another. If a divided by zero occurs, it stores a special error value 0 at both addresses. Code explanation. Load divided move A, comma 74H loads value from memory addresses 74H divided into a accumulator A. Load divisor move B, comma 75H loads value from memory addresses 75 divisor into a register B. Perform division div divides A by B. If B equals 0, then the 0 V overflow flag is set division by 0. Check for division by 0 JZ0 error. If the OV flag is set division by 0, jump to the 0 error label. Stores results if no error, move 76H, A. Move 77H, B. SJMP end program. Stores the quotient from A to addresses 76H. Stores the remainder from B to addresses 77H. Jumps to the end of the program. Handle division by 0. 0 error. Move 76H is 00H. Move 77H means 00H. Stores 00H at both addresses to single an error. End of the program. End program JSMP $and program enters an infinite loop marking the end. Normal division example input 74H equals 06 or 6 75H equals 02. After execution, A quotient is 3, B remainder is 00. 76H is 3, quotient saved. 77H is 0, reminder. Division by 0 example input is 74H equals 6. 75H is 00. After execution, OV flag set division by 0 occurred. 76H is 0. 0 error. 77H is 0 error. The conclusion is this assessment enabled the design and successful implementation of fundamental assembly language programs for the 8051 microcontroller, addressing a variety of CPU and memory operations including arithmetic divisions, local flag and flow analysis. Each program was written the proper commands and tested for accurate functionality using simulation tools. Key learning from the experiments including efficient usage of CPU registers to minimize process time and resources, com- communication memory optimization through the use of direct and indirect addressing modes, understanding of branching techniques and the use of status flags. for robust program controller and error handling. Simple execution was verified in MCU 8051 simulation software, and results were documented using screenshots and result tables for each program scenarios. These processes highlighted the practical value of simulation tools in validity microcontroller based solutions. Looking ahead, this foundational work can be executed to more complex programs. Future scope including processes, large datasets, exploring advanced instruction sets, improving performances, and integrating additional CPU features such as timer or counter operations and interpret handling. These skills are essential for developing efficient and reliable embedding systems in real world engineering applications. Thank you.